let's go and compare the two titration curves. I was really careful when I set up the strong acid example with HCl and the weak acid example with acetic acid to use 0.200 molar sodium hydroxide with each of them, and both of the acid concentrations were 0.200 moles per liter. Additionally, I looked at the pHs at the same places. So let's compare our results and see how they're similar, different, whatever. So initially, the pH of the acids before the titration started, it's 0.699 calculated for HCl and 2.728 calculated for acetic acid. Well, that makes sense. Acetic acid is a weak acid, HCl is a strong acid. So before the titration starts, the acetic acid will have less dissociation, less hydrogen ions, therefore a higher pH. Then we went 12.5 milliliters in. And this was also known as the half equivalence point because it's halfway to the equivalence point. And at that point, well, the pH is still higher for acetic acid than HCl. And it makes sense because titration-wise, you're titrating the same amount of acid. And then when you look at what's left over, well, you don't have as much of the acid left over. And acetic acid's a weak acid, so that makes sense. There was something, though. At the half equivalence point, for acetic acid, pH equals pKa. And we don't worry about that for B because we don't worry about a Ka for the strong acids. We only worry about the Kas for the weak acids. So this is a way to determine the Ka value for a weak acid. You find the equivalence point, you take halfway to the equivalence point, figure out the pH, that's the pKa, you can turn it into the Ka. Now I did this point last, but on the curve it comes up before the equivalence point. This was at 24.9 milliliters. So what's the pH when we were 1/10 of a milliliter away from the equivalence point? And for HCl, it's still the pH is still way down there, 3.4. But it's gotten a lot higher. For the acetic acid, it was 7.2. So we add 1/10 of a milliliter of base to each of these to get to the equivalence point. And the HCl pH jumped from 3.4 to 7. And for acetic acid, it went from 7.2 to 8.88. Still a big jump. And what do we get from this? Well, when we have a strong acid, strong base titration at the equivalence point, the pH is expected to be 7. And that's because when you've added just enough base to titrate the strong acid, you're left with an extremely weak conjugate base. In fact, so weak that we normally ignore it. So what we have is we consider it as a neutral salt in water. And so the pH comes from the water. But for the acetic acid titration, at the equivalence point, we have turned all of that acetic acid into acetate ion. We have to consider acetate ion because that's a strong enough base to be considered. And so at the equivalence point, the pH is greater than 7 if you start off with a weak acid. It's greater than 7 because you've turned the weak acid into a weak conjugate base. Look what happens after point C for the acetic acid. After that, the titration curves line up. And that's because once you've passed the equivalence point for the weak acid, now what you have is an excess of the strong base, sodium hydroxide. It's a strong base. It's going to totally overwhelm any weak base contributions. So that's why the titration curves overlap. So after the equivalence point, you just look at the concentration of excess base, hydroxide ion, and you get the pH from that. One additional area, and that's this area, this plateau area for acetic acid. That's the buffering region. In that region, you have significant amounts of both the acid that you started with, HC2H3O2, acetic acid, and the conjugate base, C2H3O2 1- acetate ion. So as long as you have appreciable amounts of both the acid and the conjugate base, or the base and the conjugate acid, it's a buffer. And notice how the pH doesn't change that much in that region. Now, if you look at the bottom plateau area for HCl and you say, but wait a minute, HCl is a good buffer. No, it's not. It's a terrible buffer. Look how low that pH is. The reason why the pH is low down there is because you have excess strong acid. You gotta have weak in order to have the buffer system.